Assalamu alaikum student. Today we discuss the topic that is the Malus law. First we discuss the intensity of the polarized light. Malus law says that when the unpolarized light, that is intensity I naught, when it passes through the polarizer which transmission axis has vertically, then it allowed to pass the vertically light. Then we get the vertically polarized light, that is intensity is half by the incident of the unpolarized light, that is intensity is I naught, and intensity is reduced by I naught by 2 when it passes through the polarizer. So here we write the intensity of unpolarized light is reduced as a result of polarization if unpolarized light of intensity I naught pass through the polarizer then the intensity of transmitted light will fall by a half. Now we discuss the intensity of the analyzed light. When unpolarized light, that is intensity I naught, is passes through the analyzer which transmission axis is vertically, then it allowed to pass the vertically light. When unpolarized light, that is intensity is I naught, when it passes through the polarizer, intensity is reduced by I naught by 2. Then after the polarizer, this vertically polarized light is passes through the analyzer which transmission axis also is vertically, then its intensity is not reduced, it's same as the intensity of the polarized light, that is I naught by 2. Then the vertically polarized light is also emitted by the analyzer, its intensity is I naught by 2. So here we write a second polarizing filter is known as analyzer. When the polarizer and the analyzer have the same orientation, when the polarizer and analyzer have the same orientation, the intensity of the analyzed light, that is passes through the analyzer, then the intensity of the analyzed light is same as the intensity of the polarized light. Which is the polarized light which passes through the polarizer? This is the polarized light and this is the analyzed light. Both the intensity is same because the both transmission axes have the same angle. When the polarizer and analyzer is not at the same angle, polarizer is the vertically and analyzer which is the horizontally, so both make an angle of 90 degree with each other. So when the polarized light is passes through the analyzer, then no light is transmitted because the analyzer with transmission axis is horizontal and polarized light which is the vertically polarized light, so no light is transmitted. So here we write when analyzer is rotated by 90 degree with respect to the polarizer, then the intensity of transmitted light will be 0, so no light transmitted. That is the intensity of the analyzed light when it passes through the analyzer. When the analyzer has the same angle as the polarizer, then intensity is not reduced. When the analyzer is with 90 degree with respect to the polarizers, and then no light is produced. Now we discuss the another topic in Malus law. Then when the analyzer is at any angle with respect to the polarizer, then we use the Malus law to determine the intensity of the analyzed light that is passes through the analyzer when the analyzer make an angle theta with respect to the polarizer. The intensity of the analyzed light when the polarized light is incident on the analyzer will have an intensity I naught by 2. The analyzed light will have an intensity is I naught by 2 cos square theta when it make an angle theta with respect to the polarizer. So here we write when the analyzer is rotated with respect to the polarizer by an angle theta, then intensity of analyzed light, intensity of analyzed light will be I naught by 2 cos square theta. Here we use the Malus law. Malus law is used to determine the intensity of analyzed light when the polarized light is incident on the analyzer will have an intensity I naught by 2. The analyzed light will have an intensity I naught by 2.